Let's go through some key terms that will come up through this class that we really want to have a good grip on. The sooner you can add them to your vocabulary and you kind of get what you're talking about when you hear these terms, the easier it'll be to immerse yourself in some of the literature and books and conversations we'll have on testing. So one of the terms you might see is quality assurance. I've already used the term. So it's just a fancy name for testing, right? Yeah, but quality assurance is more than just a person hammering on a system just to see if it works. It's a systematic process. It's a formalized approach to not just that the system that we built has quality, but the way we built the system has quality as well. When somebody works for quality assurance, they don't just care that the food came out of the kitchen and it tastes good and looks good and people are happy with it. It also wants to know that, hey, the countertops are clean. The food prep station is clean. The storage, the way food is stored, you don't have prepared food with raw food stored in the same location or the same shelf or things like that. Um, it's a it cares about how the sausage is made, not just that the sausage is good, if you will. And so that's something to think about when you hear the term quality assurance. It's a systematic approach to ensuring something is done with quality beyond just the product itself. Now, sometimes you'll hear the term validation. Normally, as we'll talk about here in a second, in relation to verification, validation is the choice to say, am I building the right thing? So if you're going on a trip, not just if I follow these street directions step by step, I will get to the place that the directions tell me to. That's good. I mean, I once, when my grandmother was first put in a retirement home, I put in the address and I drove to the retirement home and I followed every single direction perfectly. You have arrived at your destination, and I was at the high school. What? Why? That doesn't make any sense. Well, the issue was I didn't validate that I put in the right place. I didn't put in the address to the high school. It's just that the retirement home was so new, the GPS I had didn't know how to find it because the address didn't exist. It's not a phone GPS. This is many years ago when they were all hard coded into the device. So it took me to the center of town, which happened to be the high school. So I didn't validate it was taking me to the right place. I just followed the directions and got to the wrong place correctly. So validation is to make sure, did we make the right requirements to begin with? Are we testing the right thing? Is it something that the user really needs? Versus verification is the other aspects of, okay, you gave me the directions. Can I follow them to get to the place I wanted to go? So verification is saying, given that we assume these requirements are correct, does the system do what these requirements say they're supposed to do? And it's not just the code. It's, have we built the requirements in a way that adequately describes the needs of the customers? Is the design going to adequately fulfill those requirements? Do the test cases properly test what we expect them to test? And thus, do we get to the point of, did we deliver what we thought we wanted out there? Another couple terms that come up from time to time is measurements versus metrics, where measurements we'll talk about are the raw data that is observed and collected. I tested the system and I got a response time of 1.7 seconds or 50 milliseconds. On their own, they might sound fast, they might sound slow. It depends on context. By its own, it doesn't have any meaning. So I can tell you I'm 6 foot tall. I can tell you I weigh 185 pounds. Individually, they don't mean anything. If I'm 6 foot tall and I am a miniature schnauzer, I'm massive. If I'm 6 foot tall and I'm a tree, I am pretty small. Um, as a human, I'm perfectly average that way. So metrics is what gives measurements context. I take normally multiple metrics and I put them together to be able to give meaning and be able to make decisions based off of those things. So for example, given those two stats, you have something called the BMI, which says that I am a BMI of 24 at that, and so I am the healthy upper range of weight inside of there. I'm not a big fan of the BMI as a metric, but it is a metric. It means something and is used by that. And in software testing, we have many metrics that you may or may not entirely agree with, but they're useful in their own way. For instance, sometimes we count the number of bugs. By itself, number of bugs doesn't provide anything useful. If I'm building a very simple system and it has a lot of bugs, that's a problem. If I'm building a very complex system and has the same number of bugs, that might be a good thing. If I have 1,000,000 lines of code, I have 100 bugs. That's pretty darn good. If I have 1,000 lines of code and 100 bugs, that's not so good inside of there. So that's what you want to consider, and we'll talk about a little bit as we make decisions in our testing. Now, I want to address that question of testing versus debugging and the boundary inside of here. Because testing, as we said, is checking if the expected outcome is met. And there's typically a lot of steps that might overlap with what happens in debugging. But what's really important in testing is we capture the inputs and the expected outputs that go along with those inputs. Because debugging is basically finding out why you're saying my system doesn't work based off of your test. And so in debugging, I also want to know the inputs, and I need to find out why the expected outputs aren't happening. Now, that's not the job of the tester. The tester's job is to say, this is what I thought would happen and it didn't happen. It's the job of somebody else to go off and say why that didn't happen. It might be that the expected value is wrong. It might be the fact that something's broken inside the system. But that's the debugging process. It's a separate process from testing. Sometimes it's all done by developers. Sometimes the testers help contribute to that, depending on the nature of the testers and how much they know. But understand they are distinct. They aren't the same thing when we go about them. When you do have a problem, it typically arrives in a defect. A defect is some sort of thing that didn't happen the way we expected it to. It may or may not be a real error. It could be that I have a bad requirement. It could be that the test case was written badly. It could be that it's something that's not covered. We just never expected that to happen. I just don't know what to do. So I write up a defect to give us something to come back and address it later on. A defect is almost like a note to go and start the process of figuring out what do we do from here. So defects aren't always bad, but they certainly are something that does kick off additional work, and from that standpoint, it can slow down the release of a project and meet the expectations of just getting it done. But what they do is they give us a point to discuss on how do we get it done well and get it done right.